Hey 30-2s, welcome to a quick video where we're going to look at in our new unit logarithms, and we're going to look at the graphs of these functions so we know how they perform, and we'll talk a little bit about what we're going to do with these things. So before we look at the graphs, let's talk about, why the heck should we care about these things? Why are they important? Well, they've got loads and loads of real life applications. One really easy one that I want to look at is how tall we get as we age. So let's draw a graph here, and we'll put time down here, and we'll put our height up here in centimeters or inches, doesn't really matter. Well, what happens is as we're born, we start over here at time zero or day one, whatever, right? The second we're measured, I guess. Here's our height in centimeters. And then we start to grow. And as we're little kids, right, we grow pretty quickly. And then maybe we have a growth spurt when we're teens. But, usually by the time we're 18, 19, 20, we kind of peak, don't we? And then our height levels off and it sort of does something like this. Well, what this is right here is this is what's known as a logarithm. That's the graph of a logarithm. And so when my kids were born, we would go to the hospital and they would actually provide us a super cool chart like this. And so what was neat is they would predict using these logarithmic graphs all on one page, they could predict with pretty good certainty how tall my children would be, just like that. Okay, so the reason why we're going to use logarithms is that they model all sorts of things in nature. So this is one easy example. The other things we're going to work with logarithms will be things with large scales. So I want you to think earthquakes, pH, and decibel are the big three that we'll explore in this unit. So there's what a logarithm looks like. What I need you to know is, what is a logarithm? Well, really, a logarithm is an inverse of an exponential function. And what that means is they undo each other. So I want you to think, what does that mean? What does it mean to undo something? Well, adding and subtracting undo each other. Multiplying and dividing undo each other. Squaring and square rooting undo each other. So a logarithm and an inverse, or a logarithm and an exponential, are inverse functions. They will undo each other. Okay, the reason why we're going to use that is we're going to solve for unknown exponents. Last unit we solved for unknown exponents, but there was times where we couldn't solve it algebraically. This is where a logarithm is going to come into play. Okay, so now we know what the graph looks like. Now we know what a logarithm is. And here's how we're going to write a logarithm. So we're going to say y is equal to a log base b. So this is the base b of x. And this here, what's inside the parentheses, is known as our argument of our logarithm. It's our input, if you want to think of it that way. Okay. So again, I would say this is a times log base b of x. That's it. Okay, so what we're just going to do really quickly here is we're just going to explore how to put these into our calculator. And depending on the calculator model that you have, I'm going to show you how we can all put these in our calculator. So let's go and look at just graphing the most basic graph. So grab your calculator and let's put in log x. So log is just down here on your TI on the left-hand side, log x. And we hit graph. And when we do, we get this graph here. And it's kind of interesting that after all these years that these TIs don't graph these logarithms very well. If you look, it sort of looks like the graph stops really close to the y-axis there, doesn't it? Okay, I need you to know that your graph on your calculator isn't showing you what I need you to know. This is really important. This isn't showing you what this graph really truly looks like. Here is what this looks like. if we zoomed in enough times on our calculator, here is what this would look like. This graph gets incredibly close to the y-axis and never touches it. Just like in exponentials, our graph would get close to the x-axis. In this case, a logarithm, we're going to get close to the y-axis and never touch it. And I need you to know that the original x-intercept is at 1. So our calculators do a really poor job of graphing these things. And remember, there is an imaginary line here on the y-axis, like that we shall not pass. That's called an asymptote. I don't really need you to tell me much about it. If anything, I just need you to know that it exists. There it is. Okay, now, wait a minute. Up above, he said there was a base, and I just graphed log 10. There's no base there. Well, yes, there is. What we do to keep things simple in math, like we're lazy, right? We're mathletes. There is really a base there. It's really base 10, but we don't write it just to save time because we're lazy. So when you don't see a base, it's really base 10. This is known as a common logarithm. Okay? So all logarithms are base 10 if we don't see a base. Now, what about if we do have a base? Okay, how do I get this in my calculator? Okay, this depends on the type of model that you have. So I'm going to do this in two different ways. So first I'll do this if you have a TI-84, a TI-84 Plus, or a color TI. This is the easiest way to put it in your calculator. Now, if you have a TI-83, I'll show you what to do in a minute. So if I have a TI-84 or better, what I'm going to do is I'm going to hit my math button and I'm going to hit my up arrow. And you see right there, it says log base. Look at that. And so now we can put in any base we would like, and we hit enter, and there we go. Now notice the graph looks pretty much the same as the other graph. So what the base is doing is it's certainly changing how fast this graph is growing. I'll even show that to you. So if I compare that to just regular log x, you can see that it's growing at a different rate. Okay, that's all I really need you to know about the base in a logarithm. We don't explore that idea too much in 30-2. So again, if I was in a TI-84, I'm going to use my log base button. But what if I don't have a TI-84, or I just really need to know this anyway? This is important, whether I have a TI-84 or not. Okay, if I have a TI-83 or a different type of calculator, I'm going to use something known as change of base. And here's how this goes. What I'm going to do is I'm going to split this log up into two different logs, like this. And it's on my formula sheet, and I'll explain in a later lesson how this works. But for now, what I did was the argument, the x, went to the numerator, and the base went to the denominator. And if you notice, what I did was I made it into a common log. So if I wanted to graph this on a TI-83, what I would do is I would split this up into two parts. So what I'm going to do here is I'm going to do change of base, this is called. And like I said, I'll explain in a later lesson where change of base comes from. And y1 and y2 look different, but when I hit graph, guess what? They are the same. So that's how you would put that in your calculator if you don't have the log base button. Okay, easy peasy. Now, what are the domain and range? I need you to have this memorized. This is important stuff. So the domain, well, x gets really close to 0, but never touches it in 30-2 ever. And my range, well, my range is simply an element of the reals. Okay, so I need you to know that. I also really want you to know that the original x-intercept is at 1, 0. That's important to know. Okay. The a value out front, which I haven't graphed here, will affect the shape of the graph, but it's really easy. Again, it'll change how fast something is growing or decreasing. Okay, but I'll let you explore that in the lesson. It's rather easy. Last thing I want to talk about is something called a natural logarithm, which we'll see when we do regressions. Now, a natural logarithm is a log, but it's a very special log with base e. E is a number, 2.718281828459045, yada, yada, yada. It keeps going forever. And it's very special in nature. And since it's so special, they called it a natural log, and they wrote it like this, lnx. Why ln? It's natural log. Why is it ln? Well, because it was a French guy and a Swiss guy, and so this was a logarithm naturel. Okay? And so on my graphing calculator, it's right underneath the log button. So I could graph this as well. And so it's just right there, ln. Some people call that ln x, lnx, natural log. There it is. So a natural log is what we will see when we are doing regressions, but otherwise we don't need to talk about them. That's the only time we'll see them. Okay, friends, there is a basic video about the graphs of logarithms.